Okay, hello and welcome back. In this video, we're covering section 6.2 on the multiplication of polynomials. So last video, we described what a polynomial is. We added them and subtracted them. So this time we'll work on multiplying them together. So we'll start by multiplying a monomial with a polynomial. We'll multiply two polynomials together. We'll see the special case of multiplying two binomials together using an acronym called FOIL. And we'll find the product of more than two polynomials. So let's start with what's probably the simplest version, where we have a monomial multiplied by a polynomial. So remember, a monomial just has a single term, so we have 2k squared, that is a monomial, and then it's being multiplied by this trinomial, 6k squared plus 5k minus 3. So we have some single term in front of this parentheses with multiple terms inside. Well, we've seen this before. If we had something like 3 times x plus 2, we distributed that 3 to both terms. That gave us 3x plus 6. So the same idea applies here. We just need to distribute to each term. And as we do this, we'll apply rules of exponents and see what that will produce. So meaning here, this 2k squared will multiply by each term inside the parentheses. So I can write it like 2k squared times 6k squared plus 2k squared times 5k plus 2k squared times negative 3. So each term gets multiplied by that 2k squared. And then let's just multiply and simplify. So here I have 2k squared times 6k squared. The 2 and the 6 will multiply to give me 12. And then k squared times k squared. Remember when we multiplied two things that have the same base, you add the exponents together. So that will give us k to the 4th power. Then for our next term, we have 2k squared times 5k. So the 2 and the 5 will multiply to give us 10. And then k squared times k to the 1st power, 2 plus 1 gives us 3. So 10k cubed. Then for the third term, 2 times negative 3 will give us negative 6. And then we just have that k squared. We don't have another k term to combine with. So 12k to the 4th plus 10k cubed minus 6k squared. So we just need to distribute to each term. And then combine our variables using rules of exponents. So since we're multiplying, we'll be adding the exponents together. All right, in part 2, we're going to multiply two polynomials. So let's see their described procedure. They say to multiply two polynomials, multiply each term in the second polynomial by each term in the first polynomial. Then combine like terms. And they say to write the answer in descending powers. So let's see what they mean by that. We have, in our example, n squared plus 5 times 2n cubed plus n minus 9. So we have a binomial multiplied with a trinomial. So when we just had a single term, it distributed to every term, and we're basically still doing that. We'll just do that for however many terms we have in our first polynomial. So meaning this, make a little more space just to show. So the n squared would distribute through, so we would multiply with the first term, multiply the n squared with the second term, multiply the n squared with the third term. And then we'll do the same thing with the second component. So this 5 will multiply with the 2n cubed, then the 5 will multiply with the n, then the 5 will multiply with the negative 9. So let's do that. So first we'll take the n squared and multiply by every term in the right polynomial. So just to write everything out, we would have n squared times 2n cubed plus n squared times n plus n squared times negative 9. So we put the n squared through to everything. Now let's just do the same with the 5. So plus 5 times 2n cubed plus 5 times n plus 5 times negative 9. So let's do this multiplication. This will give us 2n to the 5th power, adding the exponents together, plus n cubed, so that's n squared times n to the 1st power, which should make that 3. Then minus 9n squared, those will just attach to each other, plus 10n cubed. Then plus 5n, and then 5 times negative 9 will give us negative 45. Now let's just combine like terms. So I have 2n to the 5th power, no other n to the 5ths. I do have this plus n cubed plus 10n cubed. Looks like those are the only things that will combine. Then we'll have minus 9n squared plus 5n minus 45. So let's combine those like terms. This will be 2n to the 5th plus 11n cubed minus 9n squared plus 5n minus 45. So just distribute each term from the first polynomial to the second polynomial. We have to do that for 2 terms here, and then combine everything that's like terms. So there's also a vertical method. We can look at example 3. They want us to multiply a cubed minus 4a squared plus 5a minus 1. And we're multiplying this by 3a plus 7. So just another way to show this, we're basically going to do the same thing, just working from the right side. So we'll start with this plus 7 and multiply it by every term above it. So that would give me, I guess I'll go from left to right. So 7a cubed minus, so 7 times minus 4a squared will give me minus 28a squared. 7 times 5a will give me 35a, and then 7 times negative 1 will give me negative 7. Now I'll do the same thing with my second term as a second line here. So 3a times a cubed will give me 3a to the 4th power, and I'm going to write that out in front here, where like the 4th power term would be. Then 3a times negative 4a squared will give me minus 12a cubed. And 3a times 5a will give me 15a squared. Then 3a times negative 1 will give me minus 3a. So there's no constant term here. Technically, we could say like plus 0. Now we add these up vertically. So the 3a to the 4th power doesn't add to anything. 7a cubed minus 12a will give us minus 5a cubed. Or 7a cubed minus 12a cubed. And then minus 28a squared plus 15a squared will give us negative 13a squared. And we have plus 35a minus 3a, so positive 32a, and then minus 7. So 3a to the fourth minus 5a cubed minus 13a squared plus 32a minus 7. So just to show you can set things up vertically like this, I kind of prefer writing things out in this way, distributing, but you can try different methods and see which one feels better for you. So when we multiply two binomials, we'll repeat the same process we just did, but they use this acronym called FOIL, which stands for first, outer, inner, last, which is directions on what to multiply together. So for example, in part A, we have p plus 5 times p minus 2. So we're really just repeating that process that we did last time, where we took the first term, distributed it to both terms, and then took the second term, distributed it to both terms. But if you notice the pairings, when we multiply the first p with the first p on the right side, those are the two first elements. That's like the f. Then when we distribute the p on the left to the minus 2 on the right, we're multiplying the two outer terms. There's our O. Then when we take the second term, the 5, and we're distributing that to both terms, when we do that first multiplication, notice those are the two inner numbers, inner meaning they're on the inside. And then the 5 distributes to the negative 2. Those are the last two terms. So it's just a way to remember the particular order in pairings in the multiplication. First, outer, inner, last. So the first two, p times p, will give us, let me just write out what that would be, p times p. Then we would get plus p times then minus 2. Those are our outer terms. Then the inner is the 5 times p. And then the last is 5 times negative 2. So that would give us p squared minus 2p plus 5 times p minus 10. We have some like terms in the middle, so p squared plus 3p minus 10. Notice when we multiply two binomials, we get a trinomial as the result, at least in this case. All right, let's keep practicing. Let's look at part B. So we have 4r minus 3 times r minus 1. So the first two multiplied would be the 4r times r. Then the outer will be 4r times negative 1. Then the inner is, let me just write this as our minus 3. So minus 3 times r. Then the last would be minus 3 times negative 1. That's our first, outer, inner, last. So that will give us 4r times r is 4r squared minus 4r, because we're multiplying by the negative 1, then minus 3r, and then plus 3, negative 3 times negative 1. And then we can combine those two middle terms. So we'll get 4r squared minus 7r plus 3. Part C, I'll just copy it down here. It was asking for a plus 4b times a minus 3b. So the first two multiplied would be a times a, then the outer, a times negative 3b, then the inner, 4b times a, then the last, 4b times negative 3b. So that will give us a squared minus 3ab. This is 4 times b times a, but we can write it with the a first, plus 4 times a times b. That'll help me see that it will combine with that previous term. Then the last term, we have 4b times negative 3b. So 4 times negative 3 is negative 12, and then b times b will give us a b squared term. So this will combine to a squared minus 3ab plus 4ab will leave 1ab left over, plus ab minus 12b squared. And then part D had 2x plus 9 times 3y plus 5. So first two terms, that will be 2x times 3y. The outer will be 2x times 5. The inner will be plus 9 times 3y. And then the last will be plus 9 times positive 5. So that will give us 6xy plus 10x plus 27y plus 45. And then notice here we actually don't have any like terms. This will be where we would stop. We don't have any terms that have the same variables to the same powers. We have an x and a y term and an xy term and then some constant. So none of those will combine. All right, our last section is finding the product of more than two polynomials. So the key here is just to go like one step at a time. Just multiply 2 at a time. So let's look at what we have. We have 3t squared times 5t plus 7 times t minus 2. So I have 3 polynomials multiplied. Let's just multiply these first two. We'll get some result, and then we can multiply that by the third one. So here, the 3t squared would just distribute to each term inside. So I can write that as 3t squared times 5t plus 3t squared times 7. And this will be multiplied by t minus 2. So that should give us 15t cubed plus 21t squared times t minus 2. You don't have to write out this intermediary step. If you can already see how things will combine as you distribute, you can jump to that one. Just kind of writing it out to be more explicit in terms of what's happening here. Okay, now we have our first term times our second term. They're both binomials, so we would FOIL them out. Meaning we'll multiply our first two terms, 15t cubed, we'll multiply by t. Then our outer will be 15t cubed times negative 2. Then our inner will be the 21t squared times t to the first power. Then our last will be 21t squared times negative 2. So that should give us 15t to the fourth power, because we have t cubed times t to the first power, minus 30 t cubed, 15 times negative 2, plus 21 t cubed. And we have 21t squared times negative 2, so minus 42t squared. So what like terms do we have? We don't have any other t to the fourth power terms, so we'll still have 15t to the fourth. Then we have negative 30t cubed plus 21t cubed. So that should leave us with negative 9t cubed, and then minus 42t squared. So we can just multiply 2 at a time if we have multiples. We could have even more than this. We could have 6 of them multiplied together. Just multiply 2 at a time, and it'll keep reducing until you just have 2 final polynomials multiplied. Then from there, just multiply and simplify. All right, so we multiplied a monomial by a polynomial, just distributed that through, multiplied 2 polynomials, and when they're both binomials, we can apply the FOIL acronym. And then we finished by finding the product of more than 2 polynomials together. Okay, that's it for this video, and I'll see you next time.